All right, so in this video, our focus is section 1, 2, and so this all covered transformations of graphs. And so for number 1, we're looking at an error analysis. And so we had a student that transformed this blue f of x, which was this equation here, the absolute value of x plus 2 plus 1, and they were trying to apply this transformation, f of negative x. And so they're saying that this red G is incorrect. And so if you remember when we did the flow chart, when we were making modifications to f of x, if we did anything on the inside, that should have affected the graph horizontally. And if there's anything that we did to modify the outside of the function, that should have affected it vertically. And so right away, looking that there's this negative inside with the x, I can see that it shouldn't have been a vertical reflection, it should have been a horizontal reflection. And so we're going to use Desmos to show this, and we have the absolute value of x plus 2 plus 1 graphed already in blue. And so what I'm going to do to get g of x is I'm going to plug a negative into x. And so I'm going to change this red just to help us see that. Okay, so now you can see that our original blue function is folded over the y-axis, which makes a horizontal reflection. Now another way that you could have done this, and we went over this in class, is you could have written the specific equation. I cheated and just told Desmos to take whatever f was and plug in a negative x, but you could have plugged in that negative x yourself to also see what would happen. And you can see that the red and the green graph are the same. So you can either use function notation to show that we're multiplying the x by a negative, or you could actually perform that operation. Okay, so moving on to the next one, we have number 2, and so it's told us to graph the parent function, which is in blue, the absolute value, and then it's asking us to describe the transformation. Okay, so what I see when I look at our new g of x, compared to the parent, we now have a negative symbol on the outside, we have a plus 2 on the inside, and we have a negative 1 on the outside. And so again, going back to what we talked about over here, if we're doing something on the outside of the function, that's going to affect it vertically. And if we do anything on the inside of the function, that's going to affect it horizontally. So first, let's start with this negative. I know that that is vertical. It's going to affect it in the vertical direction or affect the y values. Same thing with this negative 1 is going to affect it vertically. The plus 2 is the only thing that was inside with the x, so that's going to affect it horizontally. Now I'm going to go ahead and go back to Desmos, and we're just going to review what adding, subtracting, and multiplying will do to a graph. And so here's just the parent function of absolute value of x. Notice that when I'm on the inside of the function, it's going to affect it horizontally. So if I add 5, it shifts it to the left 5. If I subtract 5, it shifts it to the right 5. Same thing if I were to add 2, left 2. Subtract 10. Goes to the right 10. Now notice that that is kind of backwards. You might think that subtracting 10 would shift it to the left, but it has an opposite effect. Now if I multiply by x, 2, it changes the width. 3, same thing there. 5, same thing there. Let's say 0.5 makes it wider. So again, a smaller number makes it wider, which may be the opposite of what you think, but anytime I'm messing with the inside of the x, it's affecting it in the horizontal direction. So now, if I start modifying the outside, plus 7, it goes up 7. Subtract 10, it goes down 10. So add 5, it goes up 5. So that's intuitive. Adding numbers makes it go up, subtracting numbers makes it go down. So now let's go ahead and multiply. Multiply by 3, looks like it kind of is pulling it upwards and stretching it vertically. If I multiply by 0.5, it's smashing it down or compressing it down vertically. So going back to our problem, we can see that this plus 2 is a horizontal translation, and we'll move it to the left 2. This minus 1 is a vertical translation and is going to shift it down 1. And then a negative is kind of going off of what we were looking at in that first example. A negative is going to cause a reflection. And since this negative is on the outside, it reflects it vertically, so up and down. And so this would be a vertical reflection. So if you wanted to be formalized with how you label this, you would say a horizontal translation, left 2, a vertical translation, down 1, and then a vertical reflection over the x-axis. All right, so this would be a good time for you to get your own practice with looking at each of these g of x functions. Notice that they are all modifications of the parent function x squared. And so if you want to pause this video and write down what you think is happening to the graphs, then you could graph them in Desmos and then come back and verify that your graphs and transformations are correct. So I would pause this video at this time, use number 3 to practice, and then you can continue playing the video to check your answers. All right, so to go over these problems now, you can check your answers, and if you got them all right, great, you can stop watching, or if you got a few wrong, you can continue listening for the explanation. And so since this negative 5 is inside with the x, we know that it's going to be horizontal. We are subtracting 5, so we think opposite, which means it's going to move it to the right 5. Down here, I'm going to jump down to part C. Same thing, we've got a plus 1. It's inside with the x, so we know it's going to be horizontal. Think opposite. Since we're adding 1, it's going to shift it to the left 1. I'm then going to switch colors here. The 2 on the outside, since it's on the outside, is considered vertical. It's going to affect it in the y direction, and we're multiplying, so it's a dilation of times 2. So it's going to make it, pull it up, and make it 2 times taller, or stretch it. I'll hop over to B here. The minus 6 is on the outside of x squared, so again that means it's vertical. And since we're subtracting 6, that ends up moving our graph down 6 units. For the last one, D, the plus 5 is on the outside, so it is vertical. I highlighted the wrong one there. And so it's a vertical translation, and we're adding 5, so it moves it up 5. We also have a negative on the outside, which means a reflection, and since it's on the outside, it's a vertical reflection. The 2 is also on the outside of the function, so it's a vertical dilation times 2. And then the last piece of it was on the inside of the function with the x. We were subtracting, so we knew it was going to be a translation, horizontal. Think opposite, it goes to the right 3.